Hello everyone. In this video we are going to solve 5 more problems that appeared in NEET exams. So our first problem is, if energy E, velocity V and time t are chosen as fundamental quantities, the dimensional formula of surface tension will be, and 4 options are given. So to solve this problem, we need to know the dimensional formula for surface tension, energy, velocity and time. We know that the surface tension is defined as force per unit length. So the dimensional formula for surface tension will be mt to the power minus 2. Now let's assume that surface tension depends on energy E, V and time t up to some arbitrary powers of A, B and C. Then we can write S is proportional to E to the power A, V to the power B, T to the power C. Now we need to put the dimensional formulas for surface tension, energy, velocity and time. Now the dimensional formula for surface tension is mt to the power minus 2. For energy it is ml square t to the power minus 2, and velocity it is L t inverse, and for time it is t. Now if you calculate the powers for m, L and t, then you will get m to the power a, L to the power 2a plus b, t to the power minus 2a minus b plus c. Now comparing similar quantities from both sides of the equation, we can write a equals to 1, 2a plus b equals to 0, minus 2a minus b plus c equals to minus 2. Now if you solve these equations, then you will get a equals to 1, b equals to minus 2 and c equals to minus 2. So the dimensional formula for surface tension will be E v to the power minus 2 t to the power minus 2. Therefore option 4 will be the correct answer. Now let's go to our next problem. Our next problem is, if force F, velocity V and time t are taken as fundamental units, then dimensions of mass are, and 4 options are given. So to solve this problem, we are going to use a most familiar relation, F is equals to ma, that is force is equals to mass times acceleration. Now this can be written as F equals to mv by t, as acceleration is velocity by time. Now this can also be rearranged as m equals to ft by v. Therefore from this expression, one can easily write the dimensional formula for mass m, which is F v inverse t. Therefore the correct answer is option 2, that is the dimensional formula for mass in terms of force, velocity and time is F v inverse t. Our next problem is, if dimensions of critical velocity Vc of a liquid flowing through a tube are expressed as eta to the power x, rho to the power y, r to the power z, where eta, rho and r are the coefficient of viscosity of liquid, density of liquid and radius of the tube respectively, then the values of x, y and z are given by, and we have to choose the correct answer from these given 4 options. Now to solve this problem, we are going to use the principle of homogeneity of dimension, according to which any equation containing physical quantities will be dimensionally correct if the dimensions of all the terms occurring on both sides of the equations are same. Now according to the question, it is given that Vc is proportional to eta to the power x, rho to the power y, r to the power z. So to find the value of x, y and z, we need to know the dimensional formula for these 4 quantities, that is Vc, eta, rho and r. The dimensional formula for coefficient of viscosity of liquid eta is given by m L inverse t to the power minus 1. The dimensional formula for density of liquid rho is given by ml to the power minus 3. For radius, it is simply the dimension of length, and for critical velocity of liquid Vc, it is m L to the power 0 t to the power minus 1. Now according to the question, dimensional of Vc must be proportional to dimension of eta to the power x, rho to the power y, and r to the power z. Now if you put all the dimensional formula for these 4 quantities, and if you calculate all the powers of m, l and t, then you can write m to the power 0, l to the power 1, t to the power minus 1 is proportional to m to the power x plus y, l to the power minus x minus 3y plus z, t to the power minus x. Now if you compare the exponents of m, l and t from the both sides of the equation, then you can write 3 equations: x plus y equals to 0, minus x minus 3y plus z equals to 1, and minus x is equals to minus 1. Now if you solve these 3 equations, you will get the values for x, y and z, which are x equals to 1, y equals to minus 1 and z equals to minus 1. Therefore correct answer is option A, 1, minus 1 and minus 1. Now let's go to our next problem. Our next problem is the pair of quantities having same dimensions is, and 4 options are given. In option A, the 2 quantities are impulse and surface tension. In option B, angular momentum and work. Option C, work and torque. Option D, Young's modulus and energy. To solve this problem, we need to know dimensional formula for each quantity. So first, let us consider the quantity impulse, which is defined as force times time, and we know that the dimensional formula for force is ml t to the power minus 2, and for time it is t. So if you calculate all the powers, then the dimensional formula for impulse will be ml t to the power minus 1. Surface tension is defined as force per unit length. So if you put the dimensional formula for force and length, then you will get the dimensional formula for surface tension, which is m t to the power minus 2. The dimensional formula for angular momentum is ml square t inverse. Now work and energy have the same dimensional formula, which is ml square t to the power minus 2. And for torque, the dimensional formula is ml square t to the power minus 2. And for Young's modulus, it is ml inverse t to the power minus 2. Therefore, from all these dimensional formulas, we can say that torque and work have the same dimensional formula. Therefore, option C is the correct answer. Now our last problem is, a satellite is orbiting just above the surface of the earth with period capital T. If d is the density of the earth and capital G is the universal constant of gravitation, the quantity 3 pi over gd represents, and 4 options are given: t square, t cube, square root of t and t. Now this problem can be solved in many ways, but here we are going to solve this problem by using simple dimensional analysis. And for this we need to find the dimensional formula for 3 pi over gd. But 3 pi is a dimensionless constant, so we can drop this term. So we need to find the dimensional formula for 1 over gd. Now we know the dimensional formula for g is m inverse l cube t to the power minus 2, and d represents length, so its dimensional formula is l. Now if you calculate all the powers, then the final dimensional formula for 1 over gd will be m l to the power minus 4 t square. Therefore we can say that the quantity 3 pi over gd is proportional to t square. So our correct answer will be option A, t square. So that's it for now. See you in the next video, and in the next video I am going to solve all the problems from errors and measurements that appeared in last 11 years of NEET exam.